Hi, welcome to my channel. In the previous video, we discussed about the MNST dataset, training A, training, binary classifier, and then measuring the accuracy using the cross validation, and also confusion matrix. So now that means based on the MNS dataset, it contains 70,000 handwritten images are there. That is divided for the two purpose. That is 60,000 images for the training purpose and 10,000 images for the testing purpose. So based on this dataset, we are going to apply one classifier called as a training binary classifier. So here the binary classifier purpose is whether the given image is 5 or not 5. Like that we are going to classify the two types of classifications. One is 5 and not 5. So after training the binary classifier, then we are going to find out the performance of our model, that is a binary classifier. Okay, for that we are applying the one method called as a accuracy using the cross validation. So here we are going to find based on this method we are going to find out the accuracy of the model, but there are different approaches are there to find the performance of our model. One is the confusion matrix. So here not only confusion matrix, based on the confusion matrix there are different types of performance metrics are there. One is precision, recall, and F1 score. In this video we are going to discuss about the precision, recall, and F1 score. Now precision and recall. In this the accuracy of the positive predictions, this is called as a precision of the classifier. What is the meaning of the precision? The accuracy of the positive predictions. Now here the precision is called as a precision is equal to true positive by true positive plus false positive. In the confusion matrix, we discussed about what meaning of confusion matrix. It contains one matrix, binary classifier matrix. Okay, here it contains actual values, like these are called as actual values, and these are called as negative points, and these are positive points. And on the column side we are having the predicted values. Okay, predicted values. So here this is called as a true positive, and this is called as a true negative, this is called as a false positive, and this is called as a false negative. Okay, now based on this diagram we are going to find out the performance of the measures like precision, recall, and F1 score. Here the precision is called as the true positive by the total number of true positive plus false positive of the predictive values is simply called as a precision. Okay, now so here the TP is called as the number of true positives, and the FP is called as the number of false positive. Okay, so here actually these are called as negative elements. These are called as negative elements, and these are called as positive elements, and these are also called as actual elements, and these are called as predicted values. So here these are the okay. From the diagram we can say that 3 elements are correctly classified as 5 classes, and all these are correctly classified as not 5 elements. And actually what if this is a not 5, so this is belonging to not 5 class, but it is predicted as a class 5 class. And whereas here this actually it is belonging to 5 class, but it is predicted as a negative class. So like that we are going to get the confusion matrix for our data set like MNST data series. This is a simple confusion matrix for the sample data. Okay, now a trivial way to have perfect precision is to make one single positive prediction and ensure it is a correct one. That is a precision equal to 1 by 1. That is always it becomes a 100%. Okay, now but this would be not be very useful, since the classifier would ignore all but one positive instance. Okay, so precision is a typical used along with another metric named called as a recall. So also recall is also called as a sensitivity or the true positive rate TPR. Simply it is called as a true positive rate. Okay, now so this is the ratio of positive instances that are correctly detected by the classifier. So the formula for the recall is true positives by the total number of positive elements is called as a recall. That means true positive plus false negative. This is a true positive, this is called as a false negative, and this is called as a false positive, this is called as true negative. So here the recall equal to true positive by true positive plus false negative. So this is called as a recall. So here the TP is called as a true positive and Fn is the number of false negatives. So here this is one example of the confusion matrix. It contains a sample data set of MNST data set. It is a combination of 5 and not 5 elements, not 5 class labels. So 5 means handwritten digit 5, that is belonging to 5 or not 5. Okay, and other things are nothing but 0 or 1, 2, 3, 4, 6, 7 and 8, 9. They are the other belong not 5 elements. So here all these are not 5 elements that are correctly classified as a negative elements, and this is actually this is a negative element, but we are predicted as it is a positive, and actually these are belonging to class 5, but we are predicted as a negative, and all these elements are correctly classified as a positive elements. Okay, now so this is about the confusion matrix. So based on this information, we are going to find out the performance of all these things. So scikit-learn provides the several functions to compute the classified metrics, including the precision and recall. Okay, now from the sklearn matrix, we are going to import precision score, and recall score, and so from the precision score, you have to provide the training y underscore train and y underscore train underscore predicted value. That means training value you have to provide and corresponding predicted values you have to provide. Okay, now so now here these are the true negative, and this is called as a false positive, and this is called as a true positives. Sorry, this is called as a false positive, false negatives, and this is called as a true positive. Okay. So from this one, the total number of true positives by, that means 4096 by the total number of 4096 plus, that is true positive plus false positives, that is 1522. So that gives the precision score, that is 0.7290, and from the recall score y underscore train underscore 5 comma and y underscore train underscore predicted, that is equal to true positive elements by, that is 4096 by the total number of positive elements, that is true positive, that is 4096 plus 1295, that is false positive. Okay, so here TP by TP plus Fn, that is the recall score. So here based on the score values 0.755 is the recall score of the based on the board data. Okay, now your phi detector does not look as a shiny as it did when you look at its accuracy. Okay, now when it claims an image represents a phi, it is corrected only 72.95% of the time. Okay, moreover it only detects 75.6% of the phis only. Okay, now it is often convenient to combine the precision and recall into a single matrix. That matrix is called as a F1 score. That means combination of precision recall is simply called as a F1 score. So in particular, if you need a simple way to compare the two classifiers, at that time you are going to use the F1 score. Now F1 score is the harmonic mean of the precision and recall. Harmonic mean of the precision and recall. So F1 score is F1 equal to 2 by 1 by precision plus 1 by recall. That is equal to 2 into precision into recall by precision plus recall. Simply that is equal to TP by TP plus Fn plus Fp by 2. Now that is equal to F1 equal to 2 by 1 by precision plus 1 by recall equal to 2 into precision into recall by precision plus recall. That is equal to TP by TP plus Fn plus Fp by 2. So whereas the regular mean treats as a all values are equally. So the harmonic mean gives the much more weightage to the lowest values. Okay. So as a result, the classifier will only get a high F1 score. Will get only high F1 score if and only if both recall and precision are going to be high. Then only the F1 score is going to be high value. Okay. Now to compute the F1 score, simply we can call the F1 score function from the scikit-learn. Okay. So from the sklearn dot matrix, we are importing the F1 score. For the F1 score, y underscore time underscore 5 comma y underscore time underscore predicted value. Further, we are going to get the F1 score equal to 0.7420. Okay. Now the F1 score favors the classifiers that have similar precision and recall. So this is not the always what you want. So in some context, you mostly care about the precision. You must care about the precision. In other context, you really care about the recall. So sometimes you have more concentration on the precision, sometimes you are going more concentration on the recall. Okay. So for example, if you train a classifier to detect the videos that are safe for the kids, so you will probably prefer a classifier that rejects many good videos. So that is called as a low recall, but keeps only safe one. That is called as a high precision. That means for the sake of the kids, we are going to prefer a classifier that rejects many good videos. Okay, low, that is called as simply low recall, but keeps only safe ones. Okay, but rather than a classifier that has much higher recall, but let's say a few really bad videos shows up in your product. Okay, that is the one drawback of the one thing about the precision recall. In contrary, however, suppose you train a classifier to detect the shoplifters in the surveillance of images. Okay, it is probably fine if your classifier has only 30% of the precision, as long as it has 99% of recall. The security guards will get a few false alerts, but almost all shoplifters will get the caught. Okay, that's the aim of the recall. So unfortunately, we cannot have it both ways. Okay, one is increasing the precision automatically reduce the recall, and vice versa. Simply this process is called as a precision recall trade-off. Okay, in the next video we are going to discuss about what is meaning of precision and recall trade-off. Thank you for watching our video. Thank you.